Okay, I want to find the reaction on this beam with this given loading. Okay, so what I need to do is essentially, let me draw a free body diagram. That'll probably be the easiest way to deal with this. Okay, so with this, I'm going to start with my reactions. Okay, which is just fixed over here. So I'm going to have AX, which will likely be 0. I'm going to have AY, which I can calculate, and then I'm going to have some sort of reaction moment at A. Okay. Now, how do I deal with these distributed loads that I've got here? Okay. Well, the way I treat them is I basically say, okay, it's the area under the curve. I replace them with a concentrated load that has a magnitude of the area under the curve and a location at the center. So the center of a rectangular curve will be right about here, which is going to be 2.4 feet over. Okay, and its magnitude is going to be the area of that distributed load, which will be 240 times 4.8, right? It's just the height times the width there. Okay. Similarly, I am going to, for the triangular load, I'm going to have a concentrated load that I'll put right here, which is going to be effectively 1.2 over from the flat side. I get that from 1/3 of the height, so 3.6 divided by 3. And again, from here to here is 4.8, just so we know exactly where that's located. Okay, so that's the location of that distributed load, representing it as a point load. And its area is going to be 1/2 times that 3.6 times the 180 given right there. So now that I have that, now I can go ahead and with that free body diagram, sum the forces in the x, where all I have is AX, therefore it equals 0. Pretty trivial. In the y direction, I'm going to have AY, right? And then I'll have negative that 240 times 4.8, and that's going to be 1152. Okay. And then I add to it, because it's going upward, the other one, which is going to be 324. So plus 324, that equals 0. So that's my forces in the y direction. And from that, I find that AY equals 828 pounds. So that's the y reaction at A. Now, next thing I want is the moment equation. I'll sum the moments about A. I want to make sure I include the reaction moment that I'm looking for about A. Okay. Then I'm going to have two other moments. I'm going to have the negative 2.4 times the 1152, and I'll have a positive, and it'll be 6, because again, it's a 4.8 plus the 1.2 times the 324 in for that 324 force, right? That's going to be a counterclockwise. The 1152 is going to create a negative negative clockwise one. So solving for my reaction force MA, I get 820.8, and that's going to be foot-pounds. Okay, so with these distributed loads, all you need to do is redraw them as a point load that acts through the centroid and has a magnitude of the area of that distributed load. And then you can solve it just like we would solve any other statics problem.